We look at them for answers, for history, for signs of life. But what happens when one of them refuses to behave like the rest? What happens when a star blinks, dims, and shifts in ways no astrophysical model can explain? That's the story of Tabby's star, one of the most puzzling and controversial discoveries in modern astronomy. It began with NASA's Kepler Space Telescope, launched in 2009 with the goal of discovering Earth-like planets by detecting transits, brief dips in a star's brightness as planets pass in front of them. Kepler observed over 150,000 stars. Most followed predictable patterns. But one, a distant Sun-like star identified as KIC 8,462,852, didn't. Instead of periodic, shallow dimming events like those caused by orbiting planets, KIC 8,462,852 exhibited deep, irregular dips, some reducing its brightness by more than 20%. Even Jupiter, the largest planet in our solar system, would only dim our Sun by about 1% if it passed in front of it. What Kepler was seeing defied all expectations. Initially flagged by citizen scientists participating in the Planet Hunters project, a crowdsourced initiative to review Kepler data, the anomaly caught the attention of professional astronomers, including Dr. Tabitha Boyargin, who led the first major paper on the star. Her work brought it into the spotlight, and soon it earned a nickname, Tabby's star. The first question was straightforward: could the data be wrong? A glitch? A shadow? An error in processing? But these possibilities were ruled out quickly. The dimming events were real, verified, and repeatable. So what could cause them? Various natural explanations were proposed. A swarm of comets, perhaps, orbiting the star in a loose formation and occasionally blocking its light. Or maybe a giant ring of dust, left over from planetary formation. Others suggested a cloud of debris from a shattered exoplanet or a collision between asteroids. But none of these explanations fit the data well. The dips were too deep, too asymmetric, too irregular. The comet swarm hypothesis in particular struggled to account for the sheer amount of material needed to cause such significant dimming. Moreover, infrared observations failed to detect the kind of heat signature such dust clouds or debris should produce. And so the whispers began. What if, just what if, this wasn't natural at all? In October 2015, The Atlantic published a story that poured fuel on the fire. It quoted astronomer Jason Wright, who speculated that the irregular light curves might be consistent with an alien megastructure, specifically, a Dyson Swarm. First theorized by physicist Freeman Dyson in the 1960s, such a structure would consist of a massive array of satellites or panels orbiting a star to capture its energy. If an advanced civilization had built such a thing around Tabby's star, it would cause dimming patterns unlike anything caused by planets or dust. The media exploded. Headlines screamed about the possible discovery of alien technology. SETI turned its telescopes toward Tabby's star, searching for radio signals or any signs of intelligent life. None were found. And just as quickly as the hype had begun, it began to fade. But the star continued to puzzle scientists. In 2017, ground-based telescopes observed a new dimming event. This time, astronomers were ready. They gathered multi-wavelength data, hoping to learn more about the material causing the light blockage. The results pointed toward dust, but not the kind found in typical planetary systems. This dust appeared to block light unevenly across different wavelengths, suggesting it was made up of very small particles, unlike most interstellar dust. That seems to rule out large solid structures. But even then, the dust alone couldn't explain the entire behavior of Tabby's star, particularly a long-term trend noticed by researchers. Over several years, the star appeared to gradually lose brightness, not just in sudden dips but across the board. This slow fade, combined with the erratic dimming, was unlike any other known stellar behavior. At this point, the scientific community had largely moved on from the alien megastructure hypothesis. It was, after all, the least likely scenario, and extraordinary claims require extraordinary evidence. But the truth is, even without invoking intelligent life, Tabby's star remained a mystery. Astronomers began to revisit their models. Could a large cloud of debris, orbiting on a highly elliptical path, create the observed effects? Could a disrupted exomoon be contributing material? Could the star itself be undergoing some unknown form of variability, unlike anything previously documented? The challenge lay in the uniqueness of the phenomenon. If one anomalous star dimmed in this way, there might be others. Yet no other Kepler star, among the hundreds of thousands observed, had displayed the same characteristics. Tabby's star was alone in its weirdness. Researchers continued to explore naturalistic explanations. Some proposed that we were witnessing the end stages of planetary destruction, where a planet had been torn apart by gravitational forces and its remains now orbited the star. Others looked into models involving circumstellar disks, possibly influenced by an unseen companion star. In 2018, data from the Gaia spacecraft allowed astronomers to determine the precise distance and luminosity of Tabby's star. This helped refine the models, but didn't solve the mystery. It simply reaffirmed that the star itself was normal, a typical F-type main sequence star, and that its bizarre light patterns must come from something orbiting or obscuring it. The gradual dimming trend continued to be one of the most perplexing aspects. Between 1890 and 1989, historical photographic plates from Harvard Observatory showed that Tabby's star had dimmed by roughly 20% over the century. This wasn't just a series of random dips, the star had steadily grown fainter over decades. That kind of change is unheard of for main sequence stars. They're supposed to be stable over billions of years. So what could cause a 20% fade in just 100 years? The truth is, no one knows for certain. The mystery of Tabby's star has spurred creativity, collaboration, and controversy. It's a reminder of how much we still don't understand about the universe. In some ways, the alien megastructure theory, while far-fetched, captured the public's imagination because it highlighted the fact that we are still, even now, stumbling across phenomena that defy explanation. It's important to note that science thrives on such mysteries. They're not signs of failure, but of progress. Each unexplained observation pushes researchers to refine their models, gather more data, and question assumptions. Tabby's star has already deepened our understanding of stellar behavior, data analysis, and the limits of observational astronomy. Today, new telescopes like the James Webb Space Telescope and ground-based observatories continue to monitor Tabby's star. While no definitive answer has emerged, the favored explanation among astronomers involves complex, dusty environments perhaps generated by disrupted planetary bodies or other irregular orbital debris. But the details remain elusive. The legacy of Tabby's star is not just in its strange light curves, but in the way it brought together professionals, amateurs, and the public in a shared quest to understand the unknown. It shows us that even in an age of advanced telescopes and powerful algorithms, the universe can still surprise us. It can still whisper mysteries from the dark. And perhaps that's the most exciting fact of all, there are still places in the sky that no one fully understands. Still questions without answers. Still stars whose stories have only just begun to be told. If you enjoyed this journey into one of the universe's great puzzles, don't forget to like the video and subscribe to One Fact a Day. See you in the next video.